We finished describing the data entities in our data product, and that's composed of these four files in our product directory. And these four files include what we want to describe in EML in terms of the data tables in our data product, as well as any other entities that are providing information possibly about those tables. The next most important metadata perhaps is more about the spatial and temporal context of these data. We know a little bit about the spatial context and that we have some sort of site ID that we've given, but we really haven't talked anything about where that site is located. Um, and also we have temporal coverage. Now we have some information because there's the timestamps in our data file, but maybe there's some way that we want to summarize more generally the temporal coverage of this data set. So somebody knows what they're dealing with based on looking at the metadata alone. In terms of geographic coverage, the EasyEML tool allows us to add a geographic coverage. In this case, we have data that are coming from sites, so my tendency would be to add a geographic coverage for each site that's describing where that site is and giving its coordinates. And this will allow you to add as many sites as you want to, or as many different geographic coverages as you want to. You can add more than one for a given data product. And temporal coverage is pretty simple. It's just a begin date and an end date. So you're just trying to summarize the dates of the range of dates of data that are available in the data product. Again, this is just a generalization of the time coverage because we have much more specific information about time that's directly embedded in the data table itself. So let's go to our R code and the R markdown, this metadata.rmd, this is what's generating our README file. And we're going to need a couple of new sections here. And I like to put these in an overall section that I just call the coverage. And I want to put this before data entities because this is kind of more general information than the data entities, and it's sort of setting you up for understanding what you're seeing in the data entities. So I need a new first level heading that is going to automatically add its numbering. So I'm going to copy and paste what I already have for data entities. Again, I don't need these comments more than once. Actually, I'll delete it here because that's the first time that comment is there for doing the incremental values for the headings. And I'm going to call this coverage in general. And then I'm going to have some second level headers underneath that. I guess this is the only example I have. And this is going to be the first second level header, but I'll need two of these. Let me just clean up some of these extra comments that I only need to show once. And because this is the second one, I'm going to need to increment the header here. And the first one is going to be our geographic coverage. And the second one is going to be our temporal coverage. So again, this is information that we could just start typing in right here and have it in our README file. I could go look at the data and figure out what are the starting and end dates of my temporal coverage. And I could just look at the data and figure out the geographic coverage. But this is, again, information that I've already started collecting in this processing script. I have information about space embedded in the fact that when I do my quality assurance on my data, I have the latitude and longitude of the particular location that I'm dealing with. And I already have this information that's eventually I want to end up in my list of sites. So maybe I should develop my site or my geographic metadata in this processing file. Also, my table has the temporal data in it. So rather than me manually looking up the start and end date, I can have my code determine the start and end date. So our next step here is to start again with developing the metadata in this processing script, and we'll pass it on to our script that's generating the README file so it ends up in the README that's describing the data product as a whole. So I'm going to go down to the part of my script that's processing the metadata, as well as writing the data table. And after I've done all of the other metadata, here is where I'm going to start working on the temporal and the geographic coverage. So I'm going to need some code for that. I'll start a new R chunk. And let's just go ahead and add some time information into our metadata. So I really only need 2 bits of information here. I need a time start and I need a time end. And an R function that's going to be useful here for calculating these things are the min and the max functions. And the information about the minimum is going to be available in the time column of our data table that we've written. And we want to add one more argument to NARM or to the min function, and that's the NARM argument. And that allows us to control how it handles any NA values that are in this vector of values that I'm applying the min function to. And by default, NARM is going to be false, meaning that it's not going to remove NAs. And that means that if there are any NAs, that the result of the minimum is going to be an NA as well, because it's going to say, I don't know what the minimum is if I'm considering the NAs. More often than not, I don't want to do that. I just want to know what the minimum value is outside of all of the NAs that might be in there. So my reflex is to put an na.rm equals true in there just to make sure the code's going to do what I want, even if I'm pretty sure this doesn't have any NA values. This just makes sure that it's going to ignore any NAs if there are any NAs. And I'm going to do the max the exact same way, so I can copy and paste this code. I need the minimum of this time ignoring NAs, and I need the maximum of this time ignoring any NAs. Now I might as well put this information in the report so that I know what's going on when I run this and I can see that it's doing what it's supposed to. So I can add to the report time range for the data in this table. And I'm going to set this up as a list in Markdown. So I'm going to use the dash to indicate I'm starting a list. So I'm going to put the data start time, and I'm just going to go ahead and add a little more metadata there in terms of it being in UTC. And then I need some R code then to format the time the way I want to see it in the report. So I'm going to use the format function to reformat the time. And I'm going to reformat the start time that I just recorded right up here into a format that's a little easier to read by a human. And for that, I'm going to use %E. That's the day of the month without the leading zero if there's 2 digits. %B, that's the full name of the month, capital B. Capital Y is the 4-digit year. Capital H is an hour in a 24-hour clock. %M is the minute of the hour, and capital S, oops, forgot a colon. Capital S is the second of the minute. So this is just a more human readable format for the date time. I'm going to do something very similar to this. I'm just going to copy and paste. So the second element of this list, so I don't have a blank line of code, which means I'm continuing my list. I have another dash for the second element of this list. And this is going to be the data end time in UTC. And that means I need the time underscore end that I have just pulled out of the data using the max function above. So if I run this code, I'm going to go ahead and compile my processing with my processing rendering script here, making sure I save my processing script. Then I can go to my incremental folder, look at my processing notes, and we can see that under our metadata definition, as we're writing table and processing metadata, that the time range for the data in this table It starts on the 4th of March at 12:30. Again, this is UTC time, and the end time is November 11th at 7:35 UTC time. So that gives us our information for our temporal coverage. Now let's go back to our code and think about the spatial coverage. In this case, I think it's easiest, especially if ultimately I'm going to have more than one site in this data product, then I might want to put this into tabular form. That means if I create a data frame, it's easy enough to use cable to then turn that data frame into a table in my reports. So I need another new R chunk here. And I'm going to add to my metadata environment a variable called site. Now I don't need to do an R bind because there's only one site, so I'm just going to create this as a data frame with a single record in it. And the information that I want to track about each site is going to be the ID for the site. I need a latitude. I need a longitude. And I need a description of the site. So the site ID we have talked about before. That's the part of this deployment ID that is LLPAR01. The latitude is something we know from earlier in this script. Remember, it's up here at the top of our visualization because we needed this information to calculate what the PAR coming from space would be at this location. So we have a site latitude and a site longitude with the numbers that we need that we want to put in this metadata. So I can say the latitude is the site latitude and the longitude is the site longitude. And I have a pretty thorough description here. I'm not going to make you watch me type this out, so I'm going to cut and paste from my notes. I need to paste this together. I'm going to use a paste 0. Paste and paste 0. Paste is just pasting with, by default, there's a space between each thing you paste together. Paste 0 means pasting without anything in between what you're pasting together. And I'm already including space in my text. More often than not, I want control over where the spaces are, so I used paste 0, if you're wondering about that difference. So here, I'm saying that there's descriptive information about where the site is, and including something about how the whole thing is mounted. So here is where I'm saying something about how it was mounted. The sensor was mounted on a T-post in a pasture and riparian area of Louse Creek, about 560 meters west of the bridge for Indian Butte Road. So this is if somebody's on site and they're trying to find this, rather than having to zero in with a GPS, they're going to have some idea of how to find this based on local landmarks. So the deployment was near a stock pond and an existing fenced enclosure around the outlet from the pond to prevent interference by cattle in the pasture. And if somebody's on site, they should be able to find this. Pretty easy to see this pond and where this enclosure is. So this is where you can give like on the ground information about the geographic location of this site. Okay, so now I have site information that I'm defining. I can go ahead and put that information in this report. And again, this is in a data frame, so I'm just going to, even though there's only one row, I'm just going to go ahead and use a table. Now I know I'm going to need some more code here, so I'm going to go ahead and do a chunk here. But for now, let me just do a knitter cable metadata. Now let's see what this does. Oops, I got a bug. Let's see, 580 to 596. I probably got, yep, I got an extra comma again. So I don't need a comma there. There's no other arguments after the description. All right, I'm pretty sure that's the problem, so let's go ahead and give it another try. All right, we can go back to this report, hit refresh. And now we can see we have information about the site, latitude, and longitude. Now, the trick with this latitude and longitude is these are going to be pretty precise numbers. And 9113 is smaller than the actual precision that we had in our original measurement. So if we go back to the code, you'll see in the original code, there it is, there's much more precision than what it's showing. Now that doesn't mean it's storing it with less precision. It's actually storing this number exactly as we've defined it here in the code. It's just that's how it's by default showing us that number. And that's just a setting, a default setting in Cable in terms of how many digits of precision to show in numbers. And we have the ability to adjust that. If we say, well, we need more than precision than that to see the original number, I can adjust that. So what I want to do is use the options function to adjust the options. I can do a help on options. This is base R. It's just a generic set of options for global options for setting particular things that control how R operates in general. And there is an option called digits that controls how many digits of precision you see when you put numbers in generic, like when you just generically print out numbers. So if I do an options on digit right here, oops, no, I think it's digits. Sorry, I missed the S. It says by default, that's 7 digits. And that's why if we look at this report, you can see we're only seeing 1, 2, 3, 4, 5, 6, 7 numbers here with the decimal point. 1, 2, 3, 4, 5, 6, 7. So if we want to force R to show more precision in numbers by default, we can change that. So what I'm going to do first is I only want to change it temporarily. I don't want to permanently change this. I'm going to first record what the settings of options of digits is. Now you see when I run options on digits, what I get is a list with one element called digits with the number 7 in it. And I want to record that number 7. I don't want to record the list with the 7 in it. I want to record the actual number 7. So I'm going to get options digits and then the element called digits from that particular list that's returned. And that way digits is going to be a vector with the value 7 in, just as you see here. In fact, I can run this just to show how that works. This is the keys to understanding. Oh, I misspelled something again. I'm glad I did that. That helped me catch that bug early. There we go. Then I can change digits by saying that the digits argument to options is going to be 10 instead of 7 to add more digits of precision. Then I can run Cable, and then to get options back where it was, I can just reset digits back to what digits was before I reset it. So hopefully that makes sense. I'm resetting the default options for digits to 10. I'm running knitter, and then I'm setting it back to whatever it was before 10, before I reset it to 10. So now if I run this code, now I have all of the digits of precisions that I expect to see for this particular number. We have all the information that we need from this processing in that metadata environment. And remember, that's getting saved right here to an RDS file that we are reloading at the top of our metadata R Markdown file that's generating our README file. So all the information we need to put this in our report is there. So we can go to our geographic coverage and we can basically put the same code that we had in our processing script. in terms of saying what's the start and the end time in UTC. And this may seem redundant, but remember, you want this data product to stand on its own in terms of what's in the product folder. That processing script is just, or that processing report, I should say, is just somebody who's really diving into how the data were processed. That's when they're going to be looking at this file. This file, this README file, is where they're going to look if they just want to use the data without having to deal with those details of the data provenance. So we can put in the data coverage here, and we can also put in the temporal coverage. I'm sorry, the geographic coverage. Oh, I've got this backwards, sorry. This is the temporal coverage. So I need this down here. There we go. And then for the geographic coverage, where we can say the data product includes coverage at the following sites. And again, we're going to want to reset the default number of digits of precision if we want the full precision of the coordinates to show up. So I'm going to borrow this code from the processing markdown to reset the number of precision digits and make the table. So let's run this, render this document. And we can go back to our product folder and look at our README. And now we have a geographic coverage. Data product includes par data for the following sites, and there's the information that's in that data frame. And we have our temporal coverage saying the data start time and the data end time. And this is all, or these are being automatically generated based on a min and the max. And this is all metadata that's being propagated from our processing script to our README file. Finally, I just want to note how this automatic numbering is working. Notice that I don't have to think about which heading is under which number anymore. I've got all of that automated. So that data entities and all of this used to be the major section 2, and these were all 2s, but all of it automatically switched to 3 when I inserted this and used the same scheme for automatically calculating my numbering. So that's the reason I do that. That little bit of code that I write saves me a lot of hassle. As I build more and more sections into this, it's just going to automatically renumber the sections.